Okay, so in this question, we are giving 3 zeros, all right? The -2, 3i, minus 3i, and you notice we are given as well the conjugate, 3i minus 3i, they are conjugate of each other. We are looking for a polynomial that represents f of x with the leading coefficient going to be 1. All right. So again, we're going to use the factor theorem. So what is the factor theorem saying? If c is 0, it means f of c equals 0, right? Then x minus c is going to be a factor of the f of x, right? So it happened here, we have the zeros. The following zeros, c is going to be -2, all right, is a 0. Therefore, x plus 2 would be a factor of f of x, all right? Same thing here, c is going to be 3i. This is going to imply x minus 3i is a factor of f of x. And finally, we have c as well equals to minus 3i. And this is going to imply that x plus 3i is going to be a factor. You notice here that always I'm flipping the sign of the c, right? So now the conclusion is, if they are all factors here, then their product is a factor, right? So what is going to be x plus 2 times x minus 3i times x plus 3i. This is going to be a factor as well of f of x, right? So let's go ahead and multiply everything together. So this is the easiest part to multiply. There are two conjugates. You can, because this is a complex number, it's going to be the sum of squares. So it's going to be x squared plus 3 squared, which is 9. All right. And here, from the other hand, we have x plus 2. So then we're going to multiply it together. This is going to be x cubed. The x squared, they are 2x squared. All right, this is 2x squared. The x's, they are 9x's. This times this. And then 9 times 2 is going to be 18. All right, so the only thing we gotta verify is it the leading coefficient is 1, and yes, it is 1. So you're done. This is your f of x, all right? And that's what you were looking for. All right, we can put a box on it, and we are all set.